Yeah. Yes, you may. Yeah. Okay, so the scientific method is a method that is used to find answers, yes, to questions about the world around us. If you're just joining us, we are on page 53. Is there only one scientific method? No, there are several versions of the scientific method. Some versions have more steps than other versions. Okay, so some versions have more steps and others might have only a few steps. However, they all begin with the identification of some sort of problem or question. To be answered based upon observations of the world around us and to provide an organized method for conducting and analyzing an experiment. Have a little chat with your partner. See if you remember what a hypothesis is. What is a hypothesis? Thank you so much. A hypothesis is an educated guess. Yes, indeed. Based upon observations and your knowledge of the topic. What is data? Yeah, it is all the information gathered in an experiment. So we're going to go through one possible series of steps that the scientific method is about. Okay. So what do we want to know or explain? Use observations that you have made to write a question that addresses the problem or the topic that you want to investigate. So that would be, step number one would be, yes. Yeah, you have to define the problem or ask a question. Step number two. What do you think will happen? Predict the answer to your question or the outcome of the experiment. Yes, that is hypothesis. Make a hypothesis. How will you test your hypothesis? Develop a procedure for a reliable experiment and address the safety issues. Yes. Yeah, you're going to design an experiment. Absolutely. Design an experiment. After you design your experiment, you will follow the steps of your procedure to perform your experiment, and you will record your data and observations. What are you doing there? You finished designing the experiment, now you will perform the experiment. And you will observe. Next, you're going to take a look at your data. Is your data reliable? Does your data and observations from the experiment support your hypothesis or not? What are you doing with your data? You are analyzing your data. So analyze, and you can spell analyze with an S or a Z because we're Canadian. We can spell it the British way or the American way. S is British, Z is American. You make your choice because you're Canadian. Okay. Or at least you're studying in Canada if you're an international student, or if you have landed immigrant status. I don't know all the different statuses. Anyway, we're going to analyze the data. Now, what do you do if your data is inaccurate or your experiment is flawed? Yes? You're going to redesign that experiment, okay? But that's only if you're analyzing your data and you're like, ooh, that went wrong because I didn't think about this factor. Or, ooh, that went wrong because I didn't have the correct measuring instrument. I need something better. Yeah? So that's when you're going to redesign your experiment. What if the experiment did not support your hypothesis, but all your data was good data? Is that okay? Absolutely. You have learned something. You've learned that that hypothesis was not the correct hypothesis. And that's perfectly good for the result of an experiment, is to disprove a hypothesis. Now, if we have good data and we didn't have any problems with the original experiment, we are going to write a conclusion that summarizes the important parts of your experiment and the results. So we're going to make a conclusion. And this part is hugely important, this next one. And you're going to communicate your results. So if you're a scientist doing science and you've done a study on something, you're usually trying to get it published in a magazine or a journal, like a scientific magazine or journal. I had a student, I don't know if you guys, have you heard of the, are we good? Have you heard of the magazine, the journal Nature? Okay. Have you guys heard of Nature? Probably not, because you're not science geeks like me, okay? But Nature is this huge, it's like the big science magazine. Apparently one of my students from years ago has now been published in Nature magazine. I was like, whoa. So that just goes to prove my students are very often smarter than I am. It's just when you're in grade 9, you don't know more than me because I've been alive so much longer than you and studied for so much longer than you. Anyway, pretty cool. All right, so that is the scientific method, or at least a scientific method. And now we are going to take a look at the lab that we're going to do today. So let me go grab that lab for you. Here. 3, 4, 5, take one pass along. 1, 2, 3, 4, 5, take one pass along. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We will be working at chord 3. Okay? All right, so every individual person is going to get a copy of the lab. Okay. Every single person is going to get a copy of the lab. Everybody's going to write their name on the top of the lab. And you're going to be working in groups of 2 or 3. Okay? If you can't find a group, if you're like, oh no, I don't have a group, don't worry, I can help you find one. All right? Now, in the lab, I would like you to take a look at the box at the top. What does it say? It says, do not do what? Do not fill in the title and purpose until asked to do so in the post lab, because you need to experience this lab to know what it is about. Yes? And your title needs to be very descriptive of what the lab is about. And you won't really know that until you have finished the lab. Okay? Same thing with the purpose. We're doing this a little bit backwards here. This is more of an activity than an experiment that you've designed. Along the way, hopefully we're going to get you to design your own experiment. But we always start with our title. What do we do after the title? What comes next? The purpose. What comes after the purpose? Materials. And you'll notice that all of these are underlined, they're in bold, and they are capitalized. So those are like headings. Okay? So if you were writing your own lab, you would write these headings. You would write down your title, your purpose, your materials. What would come next? Your procedure would come next. And let's look through here. See if you can find the next thing in the lab that is bold and capital and underlined. That would be, if we go here, it's like, oh, nothing's bold and capital and underlined here. But on our next page, we have the observations. And then finally, we have the post lab. So those are the different parts of the lab. Okay. Let's go back to the very first page again. Okay. And I just wanted to make a little note here. Oh my gosh. What did I forget? Take a look at that procedure. See, I'm going to go grab something. You're going to see if you can see in the procedure what I did wrong. There's no 3. I forgot number 3. Whoops. Okay. Now, In the lab, it looks like the string is really long. Yes, the picture I drew makes it look like the string is really long. You actually don't want your string to be really long because I don't know if you know a lot about balloons, but balloons tend to be affected by static electricity. We're not too bad because it's fairly humid right now. The more moisture there is in the air, the less problem you have with static. So today's actually a really good day to be doing this. But you don't want your balloon to be too close to the table because it will be attracted to the table. You don't want it to be too close to you. You don't want it to be too close to a chair because it could be attracted to or repelled by any of those things. So to make that happen, this setup that we've got here, I'm actually going to turn it this way so that the smaller edge is towards the edge of the desk and the bigger part is towards the other side. And I'm going to turn this whole thing this way. Fortunately, somebody forgot to clean up last block, so I have this all set up so I can show you. Okay. Now I'm actually going to take that balloon off for now. And if you've been wondering why we've been tying knots all week, it's so that we'll be able to do this. Okay. Now, we are going to be working on having this absolutely level. Yes? Okay. Are we absolutely level? No. Which side is too low? The left side. So am I going to push the string towards the left side or away from the left side? Towards the left side. Okay, let's try that. Whoa, way too much, right? What happened? Like, how much did I move that? Did I move it a lot or a little bit? A little bit, and it changed it that much. So the moral of the story is, I want you to make this size with your fingers so you can just barely see through it. That's how much you want to move it at a time. Make the little, like this. Everyone, make the fingers. Show me the fingers. Show me the fingers. Just go like this. That's how much you want to move it at a time. Okay? I know you're thinking she's crazy. I can see how much. But you will remember things better if you both see it and do it. So I'm just sliding it over like less than a half a centimeter at a time. I'm just nudging it. Getting closer. So that's pretty close. Now, when you get pretty close, you're going to attach your balloons to both sides. You get some tape. Okay. Balloons are either up at the front or there's a few along the side as well. Once you've got the balloons attached, you should rebalance it if it needs rebalancing. So you're going to take a look and say, just let it settle. What do you guys think? Is this balanced? It's close. However, I think this end is a little bit lower. So I'm going to just move it just a tiny bit. Did I make it worse? I made it worse. Less than a teeny bit. And it can be a little bit frustrating, and you might be sitting there doing this for a little while, okay? So don't worry about it, just take your time. The other thing you can do is if you're like, I really want that end to be a little bit heavier, you can try putting a little piece of tape on it. Yeah, you can be like, let's see if I can make it heavier with a piece of tape. And maybe that helped and maybe it didn't. Okay, but now that we've got it balanced, You're going to take a look at it, and then if you look on page 2 of your lab, before you do anything with this, you are going on to go and make a prediction. So in the next step, we're going to be making a tiny hole in one of the balloons. We're going to take a pair of scissors and just make the tiniest snip. Do you think you should snip near the knot or away from the knot so it doesn't blow up? Near the knot. If you have problems getting a tiny snip, call me over, I can do it for you, but give it a try. Okay, we have extra balloons in case, we get a few pops and bangs along the way. So before you do the little snip, you're going to make your prediction. Now, students who are strong at predicting will be able to make multiple predictions. What does multiple mean? More than one. And you can rate the likelihood of each of those based on your prior knowledge. Okay? Now, I'm going to give you an example of a prediction. I'm not going to give you any of the predictions that you would reasonably make. But let's say I said, oh, I snipped the balloon on the right, and my prediction is that a dog will run into the room and snatch the balloon off the end. Okay? That is a prediction. Would it be a good prediction? Does that sound likely? No. You should be able to come up with 2 or 3 reasonable predictions that you think could happen. Okay, 2 or 3. So you want make 2 to 3 predictions. And you're going to say, which one do you think is the most likely and why? Do you have to be right? No, you don't. You're just making a prediction. Okay? All right. We also have some blank space left afterwards. If you're like, it's hard to actually say what's happening, I'd like to draw a picture. Okay, so you can draw a picture. And then once you've made that prediction, now you can make that little snip. Okay, and you'll watch what happens. You are going to observe the ruler and the balloon, and you'll record your observations on the next page. So let's go to the next page. What kind of writing implement will you use to record your observations? Pen. If you do not have a pen, come see me, I can lend you a pen. Okay, blue or black. Do not use pencil, do not use whiteout. Don't scribble out a mistake. What should you do instead? Cross it out with a single line. Okay? So there's your observations. Again, there's a little bit of blank space if you want to draw a picture. Analyzing is also a core competency in Science 9. So you're going to see what you can infer from your observations. Why do you think what happened happened? So if you're like, what does it mean? Do I infer? You're going to write why you think what you observed, why did what you observe happen? What do you think the purpose was of this lab? What might you be trying to find out? You'll fill that in on the front page. Anytime you have difficulty, call me over, I can help you out. Communication is another core competency. You're going to use the correct voice. That means not using I or we. Okay, you're going to enhance your communication with pictures and diagrams, and you're going to be clear and concise, not too wordy. You're only going to come up with the title once you've figured out what the purpose is. The title is going to be really descriptive of the lab. It can actually be quite long. You can make your title of the lab an entire sentence or an entire question. And again, if you're having trouble coming up with what a good title is, call me over. But usually you're basically restating the purpose of the lab, or the question of the lab is going to be your title. So really you're telling me what the lab is about just by the title. I'm not going to go through all of the other questions, but feel free to ask me questions along the way about that. Questioning is another Science 9 competency, so do your best to try for those. Analyzing, you can read through these. Your homework will be to complete the lab. Some of you might have questions once you get home, and you're like, oh, I don't know how to answer this. What could you do if you end up in that situation? You could come and see me during Flex. If you come right at the beginning of lunch, you could also come see me at lunch tomorrow. But if you come after 5 or 10 minutes, guess what? I'm going to have gone to have lunch. So if you do want to come by at lunch tomorrow, you can come see me at lunch. If you want to stop by after school today, you can stop by after school today. Is good? All right. Shall we get going on the lab? If you have trouble finding a group of 2 or 3, let me know. Scissors are here, ink is here, meter sticks are here. You know where everything else is. I need to get a box of pens at the back.
Can I use the washroom?
Yeah.
Oh, what laptop is this?
Huh?
What laptop is this?
This is a yoga.
Oh, I have a
yoga.
yoga too.
Sure.
I have a yoga too.
Oh yeah. Okay.